All right, ladies and gentlemen. Ivan, the trick with this one, well, okay. Here's the giveaway. Here's how you know what to do. You see, they're all fractions, right? And we have to solve for x. It's an equation. So the trick, like the giveaway is, you got to find the LCM, lowest common multiple of the denominators, right? And you're going to multiply everything by the LCM over 1. Everything, everything, everything. Because that's going to make the denominators go bye-bye, right? Yeah? Okay, so CNA, what is the LCM of those denominators? The LCM of 2, 3, and X. What is it? Do you know? No? Who do you think knows? You were going to say Hazel, huh? Hi, Hazel. Do you know what the LCM of 2, 3, and X is? No? I think you guys do. You're just not confident. Ryan knows. What is it, Ryan? 6x is right. We learned how to do that in the first quarter, and you had those questions on your midterm. You guys know how to do that. Like, it's the x that's bothering you. So forget about the x for now. You could at least do the 2 and the 3, right? And x is, you don't know what it is. So you just have to have it as part of your answer, because we're looking for the smallest thing that all 3 of these things can divide into, right? And so, yeah, you have to have x. All right. So we're going to multiply everything by 6x over 1. 6x over 1. 6x over 1. Like that. Hey, Roth, how is this different than finding a common denominator? What's that? Well, it's true, but that's not why it's different than finding a common denominator. Like with a common denominator, if you're going to add something like 2 over 3 plus 1 over x, you'd find the LCM of the denominators, right? But, and that would be like something over 3x, right? So you'd have to multiply this by x over x and this one by 3 over 3. So how's common denominator different than what we're doing? In fact, that's a good question. I think it's such a good question. If you guys knew the answer right away, I wouldn't write it down. But since you don't know the answer, this is a big idea. I think you should probably write this down. How is using the LCM over 1 different than finding a common denominator? The reason I think you need to know the answer to this question is because you got to know what it is you're doing, not just how to do it. So if you don't know the answer to that question, then I didn't do a good job teaching you yesterday, because I just taught you how. I didn't tell you what I didn't do a good job teaching you what you were doing. I'm a failure, Alyssa. I'm going to go crawl in a hole and just live on the street. But I'm not a druggie, so I can probably overpower most of those people and take all their shopping carts. That was funny right there. Yeah. Oh, man. That was a good one right there, Hazel. Oh, no, that belongs. Okay. So wait a minute. I did tell you the difference, but do you remember? Who knows? How is this, what we're doing right here in red, what is it we're trying to have happen? Yes, Sebastian. Yeah. Did you hear what he said? He said, quote, to get no fractions. What did he mean? What does he mean, to get no fractions? It makes the denominator go bye-bye. We're just going to have, you're right, we're not going to have any fractions. The fractions are going to disappear. Bye-bye, right? Like that, right? Whereas here, we still have a fraction. Because here we're just adding them. Here we're solving something. So we get to do some things that are a little different. Because if you do the same thing to both sides of the equal sign, it's still equal. So we can multiply by a number so that it reduces. So the answer to the question is, we are eliminating, that means getting rid of, right? The fractions. So we're multiplying by the lowest common multiple, and those things are reducing. The denominator and the lowest common multiple, they will always reduce. Because, well, the denominator is a factor of the LCM. So that's why it always reduces, and then it just goes away, and then you're just left with an easy equation to solve. Krista, is this making sense? Yeah? You sure? Okay. So you ready? Okay, because, look, here's why I make a big deal about these things. If I just taught you steps, you'd be like, okay, you'd be doing just as good as you're doing now. But then later, you wouldn't remember. You won't remember. But if you understand what it is you're doing, not just how, if you understand what you're doing, you're going to remember. You'll see. Fact. You guys know I teach a couple of college classes, and one of the college classes is a remedial class. It's like a basic class, right? And there's a student who I have, and you know him. I had him as a freshman twice. Not talking bad about him, but I don't think he passed the first time. But it's mostly just because he was not being a very serious student like a lot of you guys. He'd show up to class, and he'd kind of pay attention and be involved, but he didn't do his homework, he didn't study, he didn't pass the tests. But he learned a lot, and now in that class, he's like teaching all the other kids the stuff we're learning, which is the stuff he learned with me when he was a freshman, like 6 years ago. If you understand what you're doing, you'll remember, and then it'll get easier. Okay. Amen. End of the true story. She's over there smiling. It's true. It's true. So let's reduce, okay? Because you first multiply by the LCM, and then you remember, this is the most important hashtag in history. Reduce before multiply. So x goes into x one time, and you're just left with 6 times 1, which is 6. Claro? Yeah, Gabriel? Okay, Gabriel. Now this one's a little trickier, right? 3 and 6. 3 and 6 can be reduced. 3 goes into 3 one time. All right, so that's 1. 3 goes into 6 2 times. So this is where it gets tricky because we have 2 times x times 2, and it's a positive. So that's 4x. 2 times 2 times x is 4x. Now these are really over 1, but you don't have to write divided by 1, right? Equals 2 goes into 2 one time, 2 goes into 6 3 times, and now we have to be careful right here because we have 3 things we're multiplying. That's 21x. The hard part's done now. Cesar, are you good with this? No? What's your question?
I don't know. What did you do
On the what?
where it's 2 over 3?
2. How did I get 4x? Okay, so we were multiplying everything by 6x, correct? Okay. So I'm going to do this as scratch work. I'm going to do it over here. I'll put it in a little box. I'll answer your question right here. You ready? Here's what we got. We've got 6x really over 1, right? Times 2 over 3. Like that, right? Hello, Mr. Green.
Hey, Mr. Green.
Wow. Thank you. Oh, that's not me. I'm just teasing. Okay. So, sorry, Cesar. So check it out. It's 6x, right, over 1 times 2 over 3. So I'm going to do that over here. Look. You're reducing the 3 and the 6. The reason that you're using 6 is because it's the LCM. 3 is a factor of 6, so all you gotta do is figure out how many times does 3 go into 6. It goes in 2 times, correct? So what we have is we have 2 times x times 2. 2 times x times 2, that's 4x. Does that make sense? What other questions do you guys have? Travis, what's your question, Travis? You have no questions. All right. Luis, what's your question? Yes, ma'am.
What if like at one time like it was like divided into equally?
I'm glad you asked. So I don't know if you guys understand what she's asking, but she's saying like, what if you're doing something like this right here, right? And it doesn't reduce. Do you understand her question? Anybody know? Yes, Arath. Well, you could. You could still multiply across, but what it would actually mean is you didn't find the LCM. That would mean that your LCM is wrong. Hey, I'm glad. That is fantastic. That's the best question I've heard all day. It's only 9 o'clock, but you know, still, we should write that down. What if it doesn't reduce? That's a good question. What if the LCM doesn't reduce? Dang. Hey, Ryan, who do you think can answer that for us? What if the LCM doesn't reduce? Josh? I knew you were going to pick Josh. There was no doubt in my mind. I might as well have just picked Josh instead of picking Ryan to pick somebody, huh? Hi, Josh. How's it going over there? Good? Josh, what happens if the LCM doesn't reduce? No, that's not it, right? Wait, what did he say? I want to make sure I heard him right. Oh, you just go with it. Yeah. I mean, that's what you could do, but there's something fundamentally that's not working out right. Because look, our whole purpose of doing all this right here, right? The whole purpose of multiplying LCM over 1 is that we're making the denominators go away. So if it doesn't reduce, then what you're trying isn't working. Right? So we'll write that down. If it doesn't reduce, so what should you do? So why? Why is it not reduce? Why is it not working? Do you know, Alyssa? Dang, you can listen, huh? So what should you do if your LCM is wrong?
Figure out what's the least common multiple.
That's right. You have to fix your LCM. Maricela, that was a great, fantastic question. Hey, Gabriel. Have you ever heard people say that you'll learn more from your peers than you will from the teacher? That's one of the reasons why. This is all brand new to you guys, so there's lots of things that you wonder about that I just take for granted. I never even wonder about it because I already know it, so it's just like I don't even think about it. And that's a prime example. When you're working together, you guys come up with questions that you ask each other that I would never tell you. And when you work with each other, you ask a lot more questions. And when the teacher's helping you, you just listen. Or you might answer questions, but you're not the one doing all the thinking. Yeah. Okay. Huh. So this one worked. So from there, it's easy, right, though? We can solve this. Once we get here, it's easy. You might have trouble with this, but that's a different issue. Now, do you guys remember there's a shortcut, or not a shortcut, like a pro tip I gave you when you have two x's and they're separated by the equal sign? Do you remember what it was, Gabriel? There's a pro tip. There's something you should do when you have the x's and they're separated by the equal sign. No, you're not going to divide. So do you remember, like, if you have more than one x, you got to get them together first? Before you start doing all the other inverse operations, right? Arath is dying over there. He's like, I know this, I know this, I know this. He's like, I don't know how somebody doesn't know this. Right, Arath? What do we do? What do we do when we have something like this? You what? Yeah, of which one though? Why the 4? That's true, but why aren't we moving the 21? Oh, you guys forgot. Do you remember Maricela? Valeria remembers. What? What is it, Valeria? That's right. You move the smaller one. If you move the smaller one, your life will be easier. If you move the 21, you won't be wrong. There's nothing wrong with moving the 21x, but you're going to have a negative, you're going to have it equal to 0, you're probably going to mess it up. If you move the smaller one, life is easy. Because then, yeah, it'll work out. Yeah, okay. See, there's another example of where the teacher just assumes you understood something because we learned it a couple days ago when you obviously didn't. Which isn't your fault, it's just, well, actually it is because homework. We didn't do a very good job on the homework where we did that. Okay, anyway, 4x, you're going to subtract it from both sides, and we're going to get 6 equals 17x, is that right? Jasmine, this one I don't like. Wait, I must be wrong. This is what I hear students say all the time. I hear students say this all the time. Wait, mister, I don't think I'm right, because my answer is a fraction. That can't be right. I hear people say that all the time. But that's right. That is right. That's it. We are good to go. Okay, to summarize, right? This is what we learned how to do yesterday. This was a little review. If you see a fraction, like this, right? And the denominators are different and you have to solve it. What you're going to do is you're going to find the lowest common multiple of all of the denominators. You're going to multiply, you're going to reduce, and then you'll have an easier equation. You're getting rid of the denominator. We good with that, Krista? Rock solid or Gucci? Both? Okay.